This is the lesson for Chapter 5, Section 2, titled Solving Systems of Linear Equations by Substitution, day number 1. So we solved systems using graphing last section, and so now we're going to solve a different way, so without the graph. But the answer is still the same. It's where the two lines intersect. The difference in here is that we're just using algebra to solve and to find out what that point is. And so we can use substitution when we have a variable by itself. So for instance here, y is by itself on one side of the equal sign. This one is also by itself, and so either one will work. So you're just going to take what y is. Y is 5x in this case, and I'm going to substitute it into the y in the other equation. Now why did I put in for y? Well, that's because y equals 5x, so I can put 5x in for y in the other equation, and then solve for x. And so I'm going to rewrite that top equation, but in place of y, I put 5x. So now I just have to use some opposite operations. So I'm going to go ahead and subtract the 2x from all sides, and that'll get the x's all on one side of the equal sign. And so now I have 3x equals 3. So when I divide by 3, I'll get x. X is 1. Once I have that, take that 1 and substitute it back in. Doesn't matter which x you pick. Either one's going to give you the same answer. So I'll pick this one here, y equals 5x. So I'm going to rewrite this as y equals 5 times 1, which just makes 5. So the point is 1 comma 5. It's the x component and the y component together as 1 in making an ordered pair. So this is where the two lines will cross. But we want to check our solution. So we've taken the 1 and we put it in for this equation here. So we know that's going to end up being the same value, 5. Let's check the other one. So in place of the y equals 2x plus 3, I'm just going to take the ordered pair and put the 1 in for x and the 5 in for y. And so I'll check to see if I did it right. So 2 times 1 plus 3, well, that does make 5. 2 plus 3 is 5. So when 5 equals 5, we know both equations will work since we used the first or the second one to find the 5 in the first place. Well, we know this one works as well. So 1 comma 5, that's where the two lines cross. So we'll try this one a little bit different here. So y equals 1/2 x minus 5. See how y is by itself. I can't use this equation to substitute because neither of the variables are by themselves. So I'm going to take this 1/2 x minus 5 and we put it in for y in the other equation. And so I'm going to rewrite the equation. This top equation becomes 4x plus 2, but in place of the y, I'm putting the 1/2 x minus 5, and then this all equals 0. So I can go ahead and do some opposite operations here. So actually, before I do that, let's go ahead and distribute. So I got 4x plus 1x, I got that because half of 2 is 1, minus 10. And so now I'm going to do some opposite operations and collecting of like terms. So I'm going to collect these two terms right here, and that makes 5x, and I'm also going to add the 10 to the other side. So that leaves me with 5x equals 10. So I divide by 5, and we'll have the answer, x is 2. So we're going to take that 2 and substitute back into one of the equations. I'm going to use this one here, 1/2 x minus 5, so I'm putting that 2 in place of the x. So I rewrite this as y equals 1/2 times by 2 minus 5. Half of 2 is 1. 1 minus 5 makes negative 4. So my point is 2 comma negative 4. But we want to check to see if we got the right answer. So take that point and substitute it into the other equation that you did not substitute the 2 in for, the x value that you came up with. So I'm going to do 4, but in place of the x I'm putting 2. Plus the 2y, but in place of y I put negative 4, and see if it does equal 0. 8 plus negative 8, yes, that does equal 0. So when you do that, you've checked your answer. So this is where the two lines cross. So far we've always substituted an expression in for y. Here we don't have y by itself, we have x by itself. So we're going to take this expression that x is and we place it into the equation down below in for the x. So 2 times by 5y plus 3, and then plus the 4y equals negative 1. So I do some work, I distribute, and I've got 10y plus 6 plus 4y equals negative 1. And so from that point I go ahead and do some opposite operations. I'm going to subtract the 6 from all sides. So that's going to give me negative 7 equals, and then 10y and 4y makes 14y. So here's a common mistake. When people divide by 14, sometimes they'll say, oh, it's 2, because 7 goes into 14, but that's not what we're doing. We're actually doing 14 into 7, so we reduce that fraction. It makes negative 1/2. So I'm going to take that fraction, and I'm substituting it back into one of the equations. I'm going to pick that top equation. So I'm going to use x equals 5 times by 1/2, and then plus 3. So here I go ahead and multiply, and 5 times 1/2 makes 5 over 2. No cross canceling there. So I'm going to change this to a mixed number, 2 and 1/2. It's easier because it's a integer I'm going to add to the mixed number, so all I have to do is add the 2 and the 3, so that makes 5 and 1/2 equals x. So the point should be 5 and 1/2, comma 1/2. Let's check and see if it's correct. So I'm going to take that point and substitute it into this bottom equation. So I'm going to rewrite this as 2, but in place of x, I'm going to write 5.5. Now I'm going to change that 5.5 to a mixed number, or an improper fraction here, so that way I'll be able to do a little bit of cross canceling, actually do the multiplication. So 2 times 11 halves, and then I have plus 4 times 1/2. And then this should equal negative 1. Let's see if it does. The 2's end up cross canceling, leaving me just with 11. Here, 4 goes into 2 one time, and that leaves me with 2. So 11 plus 2 equals negative 1. So you see how I made some sort of error somewhere, since I did not get negative 1. 11 plus 2 makes 13. So let's check out where I might have made an error. So when I look at this, I see that when I went back to my equation initially, I had negative 1/2 here. But look what I did here. I did not put in that negative sign. So common error there. And so let's go ahead and put that back in there, and that'll change this to a negative 5/2. And so when I do combine these two terms, I end up having to subtract. And so you see how 2 and 1/2, if I add 3, it's not going to give me 5 and 1/2. It's just going to give me 1/2. So let's go ahead and fix it from there and see if this does fix our error. So I end up getting 1/2 for x, and instead of the negative 1/2. So let's go ahead and fix, or instead of the 5 and 1/2. So we'll go ahead and put in the 1/2, and that is a positive, and the y term was a negative 1/2. So now let's go ahead and check to see if we ended up doing it correctly. This is why the check is very important. There's lots of little errors people can make, like I made that sign error. And actually I did the sign correct, I just didn't bring the sign down with the term. Either way, it's still wrong. So let's check. So we go ahead and plug in 1/2 in for x, so 2 times by 1/2. And then plus 4 times by negative 1/2, and we should get negative 1 as the answer. So half of 2 is 1. Half of 4 is 2, but since it's negative 1/2, it's going to be a negative 2, and this is going to work. 1 minus 2 does make negative 1. So once I get those two numbers being the same, then I know I've done it right. And so that's why it's really important to always check your answer. You see, even I can make errors there, just not bringing down that sign. So let's take a look at the last type of problem that we're going to see. It's a little review problem. And so we're going to take a look at corresponding angles. And actually all they're asking you in this problem is they're going to ask you for one angle. And so we're going to go ahead and find all the angles and find out what they are. But we're going to go over what makes that the case. And so here we can see that we have an obvious obtuse angle and some acute angles. And all the acute angles are going to equal, and all the obtuse angles are going to equal whenever we have parallel lines. But sometimes it's hard to tell which angle is obtuse and which angle is acute if it's close to 90. So let's take a look at corresponding angles. They're congruent when lines are parallel. So what are the corresponding angles? Well, let's take a look at angle 7 here. Angle 7 corresponds to 3. Corresponds means that they are in the same location. And so I'm just using the symbol for congruency here. So 7 and 3 are corresponding. We also have angle 1. So angle 1 and angle 5. Those are corresponding angles. So 1 and 5, same location. So we have two more. Angle 2 and angle 6 are corresponding. So 2 and 6 are same location, both on the upper portion of the four angles and to the right of the transversal. And the last one is angle 4 and that 100-degree angle. And so that's why it's important, because now we see that angle 4 is 100 degrees. That means all the angles that are, it's 100 degrees there, all the angles that are going to end up being the bigger angle, the obtuse angle, are going to be 100 degrees. And so alternate interior angles. Alternate interior angles are like the 100-degree angle here, the 4. Angle 4 is going to be the same as angle 5. Those are alternate interior. Same side of, well, inside both the parallel lines and opposite sides of the transversal. So I see that 5 degrees, or angle 5 is 100 degrees. And then also angle 3 is congruent to angle 6. So you see how 3 and 6 are also alternate sides of the transversal inside the two parallel lines. So alternate exterior angles are outside the parallel lines. So for instance, angle 1 equals that 100 degrees again. So I see that this is 100 degrees, and now I've done all the obtuse angles are all given to me now, or at least I know them all. And also we have angle 7 is congruent to angle 2. So you can see how 7 and 2 are opposite sides of the transversal, both outside the parallel lines. So let's find out what that missing angle is, those alternate interior angles. Well, all you do is use supplementary angles. So for instance, angle 3 is going to be, plus 4 is going to add to make 180 degrees. So all you have to do is subtract the given angle from 180, and that gives you the other angles. So that means 80 degrees is the degrees of all the other angles. And so those are some rules about congruent angle, or at least parallel lines cut by a transversal, so you can figure out what other angles are. The other congruency theorem, don't need the parallel lines here because all you need are two lines. You see how 2 and 3 are the same. Those are called vertical angles. 1 and 4 are the same also, and those are called vertical angles. So those are the types of problems you're going to see on tonight's homework. Good luck.